This naturalrefrigerants.com article is being read by an automated voice. U.S. EPA proposes monitoring TFA in drinking water. By Michael Gary, published August 7th, 2026. The U.S. Environmental Protection Agency, EPA, announced on June 26th a proposed rule to monitor 30 contaminants that are not currently regulated, but may be present in drinking water, including trifluoroacetic acid, TFA, a byproduct of some HFOs. The proposed rule entered the Federal Register on July 1st. The proposal represents the sixth iteration of the Unregulated Contaminant Monitoring Rule, UCMR 6, under the U.S. Safe Drinking Water Act, which requires that once every 5 years the EPA issue a list of unregulated contaminants to be monitored by public water systems. Once the rule is finalized, monitoring will take place between 2028 and 2030 using analytical methods developed by the EPA. EPA will collect and release data on these chemicals, including their occurrence, concentrations, and potential risks to public health, the agency said. The data will be used to determine whether to regulate particular contaminants. The information we collect through this important monitoring effort will inform the agency's future decisions to protect drinking water for Americans nationwide, said Jessica Kramer, the EPA's Assistant Administrator for the Office of Water. The proposed UCMR 6 rule will be available for a 60-day public comment period ending August 31st. The public may comment online here using docket ID EPA-HQ-OW-2023-0469. In addition, the EPA will host 2 identical public webinars on the proposed rule on August 11th and 12th. Registration for the webinars is available here. The UCMR rule calls for the monitoring unregulated contaminants every 5 years in all large public water systems, PWSs, serving more than 10,000 people. All small PWSs serving between 3,300 and 10,000 people, subject to the availability of appropriations and sufficient laboratory capacity, and a nationally representative sample of small PWSs serving fewer than 3,300 people. The EPA pays for the shipment and analysis of all samples from PWSs serving 10,000 or fewer people. One of the main sources of TFA in the environment is the 100% atmospheric oxidation of fugitive HFO, 1234YF, used in car air conditioning and commercial/industrial refrigerant blends, and to a lesser extent some other F gases. The TFA is absorbed in rainfall and distributed in surface water and soil. TFA is also a byproduct of certain pesticides and other products. TFA's persistence and mobility have led to its proliferation in the environment in growing concentrations, including surface and groundwater, plants, drinking water, beverages, food, and human blood serum. TFA is considered extremely difficult and expensive to remove from surface water, so exposure is continuous, though it has a short half-life in humans, reportedly 2 to 3 days. The list of 30 chemicals in the proposed UCMR 6 includes ultra-short organofluorine compounds, pesticides, pesticide metabolites, industrial solvents, and chemical intermediates. TFA, which has 2 carbon atoms, is one of the 7 ultra-short organofluorine compounds under consideration. Other 2 carbon compounds in this group are TFSI, PFMOAA, and PFETS, along with 1 carbon TFMS and 3 carbon PFPRS and PFPRA. Among the pesticides is trifluralin, which forms TFA when it breaks down in the environment. Addressing PFAS. The data collection effort under the proposed UCMR 6 supports the EPA's PFAS Out initiative to help drinking water systems address PFAS, per- and polyfluorinated substances, a group of more than 10,000 industrial compounds known as forever chemicals, many found to be harmful environmental pollutants. The EPA has already set enforceable federal limits, maximum contaminant levels, in drinking water for PFOA and PFOS, the PFAS most widely linked to adverse health effects, at 4.0 nanograms per liter, equivalent to 4 parts per trillion, each. However, this year the agency has proposed extending the compliance deadline for water systems to meet these specific thresholds to 2031, and has proposed eliminating limits for 4 other PFAS, PFHXS, PFNA, Gen X/HFPO-DA, and PFBS. Under the EPA's definition of PFAS, which requires a compound to have at least 2 fully fluorinated carbon atoms, 4 of the 7 ultra-short organofluorine compounds, PFMOAA, PFETS, PFPRS and PFPRA, in the proposed UCMR6 are PFAS. This means that the agency does not consider TFA, TFMS, and TFSI, as well as trifluorolin, to be PFAS, though they are regarded as PFAS under the more widely accepted definition used by the EU and many U.S. states, which requires only one fully fluorinated carbon atom. In its proposed UCMR6 rule in the Federal Register, the EPA acknowledged that TFA, TFMS, TFSI, like PFAS, are persistent in the environment, highly mobile, used widely in industry, and have health effects information. Moreover, during early stakeholder engagement, the public provided both written comments and discussions in support of monitoring for these contaminants in public drinking water, the agency said. Due to the similarities in chemical structure to chemicals that EPA considers PFAS, TFA, TFMS, and TFSI, can also be analyzed in drinking water by EPA Method 563, which employs liquid chromatography/tandem mass spectrometry. This allows the EPA to better understand the frequency and occurrence of this suite of contaminants without increased costs and can inform and prioritize future resource-intensive research, the EPA said. Under the proposed UCMR6 rule, the EPA set 0.2 micrograms per liter as the minimum reporting level, MRL, for TFA. The MRL is the lowest concentration that laboratories may report to the EPA during UCMR monitoring. It is the limit for a contaminant that is considered achievable with 95% confidence by at least 75% of laboratories nationwide using a specified analytical method and is not associated with contaminant health effects information. TFA has been detected in many studies of drinking water throughout the world and in the U.S. For example, in 2025, researchers at the University of Rhode Island reported finding TFA in 66% of 320 drinking water samples, with a median concentration of 580 nanograms per liter and a maximum concentration of 2,400 nanograms per liter, 2.4 micrograms per liter. Hawaii's environmental action levels. To date, the only U.S. state that has formulated any drinking water guidance for TFA, the trifluoroacetate salt version, is Hawaii. TFA is considered a PFAS in Hawaii. Hawaii's trifluoroacetate guidance levels, what the state calls Environmental Action Levels, EALs, were first published in November 2024 by the Hazard Evaluation and Emergency Response, HEER, office in the state's Department of Health. Trifluoroacetate's EALs are listed with those of 25 other PFAS for soil and groundwater in a document called Interim Soil and Water Environmental Action Levels, EAL, for perfluoroalkyl and polyfluoroalkyl substances, which was updated in January 2026. EIALs based on toxicity factors help determine if the concentration of contaminants in soil, groundwater, or air requires further remediation or cleanup in the interest of protecting human health and/or the environment, explained John Jacob, state toxicologist in the HEER office, in a recorded presentation at Atmosphere America Conference in June. Hawaii calculated the EAL of trifluoroacetate in groundwater that is a current or potential drinking water source to be 47 micrograms per liter, while the EAL for TFA in soil is 0.99 milligrams per kilogram. However, EALs are not acted on individually by the state. Rather, they are used to calculate total PFAS risk along with the EALs of longer-chain PFAS, said Jacob. If the total PFAS risk is greater than 1, remediation is recommended, though not legally enforced, he added. Hawaii has very little PFAS contamination, as it lacks industry that generates PFAS, Jacob said. However, total PFAS determinations have been made at airport sites where firefighting foams were used. In these sites, TFA was found, mainly as the breakdown product from longer PFAS, he said, adding, the remediation part for these sites is a work in progress. Hawaii's EAL for trifluoroacetate in groundwater is higher than guidelines that several European countries have issued for acceptable levels of TFA in drinking water, except for Germany, which has a health-based guideline value of 60 micrograms per liter, with a precautionary measure of 10 micrograms per liter. Denmark has set a TFA drinking water threshold of 9 micrograms per liter, while the Netherlands has listed the lowest drinking water advisory, 2.2 micrograms per liter. In the EU as a whole, the updated Drinking Water Directive limits PFAS total, including TFA, in drinking water to 0.5 micrograms per liter as of January 2026. Member states can use this or a 0.1 micrograms per liter limit for 20 specific PFAS, not including TFA. One other U.S. state, Minnesota, has initiated a toxicity review of TFA. The Minnesota Department of Health, MDH, conducts a review of information on a chemical's toxicity to determine if a health-based guidance value for groundwater, air, or other environmental media can be developed or updated, says the agency on its website. EU evaluation of TFA toxicity. While a universal consensus on the toxicity of TFA has not been reached, references to its potential toxicity are growing, particularly in the EU. The European Food Safety Authority, EFSA, recently lowered recommended values for the safe consumption of food, beverages, and drinking water containing TFA based on recent animal studies that showed TFA reducing levels of a thyroid hormone. The EFSA has also supported another study by Italian researchers, published in November 2025, that found that TFA reduced antibody production in human-relevant in vitro tests at levels similar to those caused by PFOS, which has well-documented immunotoxic effects. The European Chemicals Agency, ECHA, concluded in June that TFA based on animal studies should be classified and labeled as toxic to reproduction, persistent, mobile and toxic, PMT, and very persistent and very mobile, VPVM. ECHA's opinion still needs the approval of the European Commission before it becomes legally binding in the EU. Under another regulation called REACH, Registration, Evaluation, Authorization, and Restriction of Chemicals, the European Chemicals Agency, ECHA, is currently considering a sweeping restriction of PFAS that would ultimately ban certain F-gas refrigerants and TFA, with a possible enactment of regulations in 2028. In defending the use of TFA-producing refrigerants, the fluorochemical industry has pointed to the UN Environment Program, UNEP, and its 2022 Environmental Effects Assessment Panel, EEAP, report. The report said that TFA is not bioaccumulative, is not expected to pose significant risk to humans or the environment at the present time, and is unlikely to cause adverse effects out to 2100.